Hello students, in this video we are going to discuss adsorption isotherm. So students, as you already know, for gases, the adsorption on a given surface increases with increase in pressure as a constant temperature. So the extent of absorption that we represent by x by m, where x is the mass of the adsorbate and m is the mass of the adsorbent. So the extent of absorption, that is x by m, of a gas per unit mass of adsorbent depends upon the pressure of the gas. So the relation between the amount of the substance adsorbed by the adsorbent and the equilibrium gas pressure at a constant temperature is called as adsorption isotherm. So a plot of x by m, that is extent of adsorption versus pressure at a constant temperature, is called adsorption isotherm. A simple adsorption isotherm is shown in a figure. This is the adsorption isotherm. So x by m is plotted on the y-axis and pressure is plotted against the x-axis. Such an isotherm is obtained when the adsorbate forms simply a unimolecular layer on the surface of the adsorbent. The pressure at adsorption equilibrium, where no more adsorption occurs, is called saturation pressure, or also called as equilibrium pressure. If you see in this graph, extent of adsorption increases with increase in pressure, and at a point adsorption becomes maximum. The pressure at which adsorption becomes maximum is called saturation pressure or equilibrium pressure. So this is the saturation pressure. At this pressure, the amount of gas adsorbed becomes equal to the amount of gas desorbed, so that extent of absorption becomes constant even though the pressure is increased. This state is called saturation state and the pressure is called saturation pressure. On the basis of experimental studies, Freundlich gave the following relationship between the extent of adsorption and pressure. For adsorption isotherm, following observations can be made. Number one is, if you see in this graph, at low pressure, the graph is almost linear and slopy. This means that x by m, that is extent of adsorption, is directly proportional to the pressure. This can be expressed as x by m directly proportional to P. This can be also written as x by m is equal to Kp. Here K is the constant. Second observation is, at high pressure, this graph becomes a straight line parallel to the pressure axis. Hence, the value of x by m become constant. That means the extent of absorption independent of pressure. So, at this point, the extent of adsorption becomes constant even though the pressure is increased. So, this is the saturation pressure. So, at a high pressure, the graph becomes a straight line parallel to the pressure axis. This can be expressed as x by m is equal to constant. Third observation is, at an intermediate pressure, x by m obviously depends on the power of the pressure, which lies between 0 and 1. That means power of pressure is fractional. So this can be expressed as x by m is directly proportional to p power 1 by n, or we can also say as x by m is equal to kp power 1 by n. Here n is any whole number. N is a constant which depends on the nature of the adsorbate as well as adsorbent. The value of 1 by n lies between 0 and 1. The above relationship is called Freundlich's adsorption isotherm. So, the value of k and n can be determined by taking log on both sides of the third equation. So, this equation after taking log can be written as log x by m is equal to log k plus 1 by n log p. If we comparing this equation with the equation of a straight line, so we can put log x by m on the y-axis and log p on the x-axis. Here m is the slope and c is the intercept. Hence, if we plot a graph between log x by m and log p, a linear plot will be obtained. The slope of the straight line will be 1 by n, while the intercept on the log x by m axis will correspond to log k. So, intercept is log k and slope is 1 by n. This is obtained by comparing this equation with the straight line equation. So students, this is all about adsorption isotherm. Thank you.